This is the solution video for Unit 7 review, problem number 10. All right, so I have the integral from 0 to 4 pi of the absolute value of cosine x dx. All right, so this one, we need to take a look at the graph of the cosine x dx in order to process this. All right, so now cosine x, right, remember, is the function that starts up here, right, and it goes down to 0, down to its minimum, back to 0, back to its max, right? And that happens within 2 pi, right? So if we're going from 0 to 4 pi, that means I'm going to repeat that cycle. So I'm going to go here, back down, back up, right? And so this is the graph of cosine from 0 to 4 pi. All right, but now I want the absolute value of this, right? So remember, what does that do? That takes every part that is below the x-axis, right? And moves it above the x-axis. So I get that, and then this part moves above the x-axis as well, right? And so really, I'm looking for the area under the curve from 0 to 4 pi. So I have these areas. All right. Now, the way that we do this is what we need to do is we need to split up the integral into these separate regions. All right. And so I'm going to take the first region, which is 0 to what? Well, cosine is 0 at pi over 2. So 0 to pi over 2, right? So we're just going to integrate from 0 to pi over 2 cosine x dx. Then, okay, this part, right, was the integral from pi over 2 to 3 pi over 2, right? That's the next time that cosine is 0. Now, the fact is that the integral of cosine of x dx would be a negative value. So we're going to subtract its value, which is going to yield a positive value, right? Then we're going to add the integral from 3 pi over 2 to 5 pi over 2 of cosine x dx, which represents this region here. Then we're going to subtract the next region, which would have been below the x-axis. So that's going to be from 5 pi over 2 to 7 pi over 2 of cosine x dx, of course. And then lastly, we're going to add the integral from 7 pi over 2 to 4 pi, right, of cosine x dx, which was above the x-axis originally, and so we're just going to add its value. So the key here is that we are subtracting the times than it would have been below the x-axis, right? And that's how we're going to evaluate this integral. Now, I know this seems like a lot here, but really the integral is the same for all of them, right? So the integral of cosine is just sine of x. So we're just going to evaluate sine of x from 0 to pi over 2. Then we're going to subtract sine of x from pi over 2 to 3 pi over 2. Then we're going to add sine of x from 3 pi over 2 to 5 pi over 2. Then we're going to subtract sine of x from 5 pi over 2 to 7 pi over 2. And then we're going to add sine of x from 7 pi over 2 to 4 pi. All right, so that means I'm going to plug in pi over 2. So sine of pi over 2 minus sine of 0, right? Then we're going to take sine of 3 pi over 2 minus sine of pi over 2. Then we're going to add sine of 5 pi over 2 minus sine of 3 pi over 2. Then we're going to we're going to subtract sine of 7 pi over 2 minus sine of 5 pi over 2. And lastly, we're going to add sine of 4 pi minus sine of 7 pi over 2. All right, so now, okay, all we need to do is figure out each of these values. So sine of pi over 2 is 1, minus sine of 0 is 0, minus sine of 3 pi over 2, right? So I'm just going to keep these in the parentheses for now. Sine of 3 pi over 2 is negative 1, minus sine of pi over 2, which is positive 1, plus sine of 5 pi over 2, that's the same as pi over 2, so that's going to be 1, minus sine of 3 pi over 2, which is negative 1, minus sine of 5 pi that's sine of 7 pi over 2, right, which is the same as 3 pi over 2, so that's going to be negative 1, minus sine of 5 pi over 2, which is positive 1, and then plus sine of 4 pi, which is 0, minus sine of 7 pi over 2, which is negative 1. All right, so then obviously we're just going to simplify here. We have 1 minus 0 is 1, minus negative 2, so that's plus 2, plus 1, that's plus 2, minus negative 2, so that's plus 2, and then minus positive 1, so, or sorry, plus minus negative 1, so that's 1. So 1 plus 2 plus 2 plus 2 plus, so we get 8. Okay, and so 8 would be the value of this integral.